Hi, this is Mr. Ward, and this is the Algebra Do Now 34.2 if you're in A or B block, or the 34.3 Do Now if you're in D block. So let's do this video key. So the first question asks you to find the x-intercepts of a quadratic. Okay, and there are several methods to do this, but one method is to factor it, and I'm pointing you in that direction by saying that, and set the function equal to 0. This is level 4 and level 5 stuff. So if you've already done level 4 and level 5, hopefully this is still familiar. If it's not, it may be worth a review. Factoring is a key tool that you'll be using going forward. So we're going to find the x-intercepts, and what we're going to do that is we're going to say y equals 0, because when y equals 0, you are literally on the x-axis, because y equals 0 is the x-axis. So we say y equals 0, and then we're going to factor this. And to factor this, we need two factors of 50 that add up to 15. Well, 10 and 5 will do. So we're going to say 0 equals, and here we'll factor it, x plus 10 times x plus 5. And now we want to use the zero product property, or ZPP, okay, the zero product property, which says that anything times 0 is 0. Since our product is 0, then x can be anything that would make this factor or this factor equal to 0. So if x was negative 10, x plus 10 would be 0, and so our product would be 0. So x could equal negative 10. But x could equal negative 5, because negative 5 plus 5 would also be 0. And so now you have two different x-intercepts for this function. Okay, because negative 10 and negative 5 will each make this whole thing 0. You could plug it in up here. Negative 10 squared is 100. 15 times negative 10 will be negative 150. So 100 plus negative 150 is negative 50. Plus 50 is back to 0. Negative 5 squared is going to be 25. Plus 15 times negative 5 will be negative 75. So 25 minus 75 is negative 50, plus 50, and that equals 0 as well. All right, now finding a y-intercept is really easy if you remember what defines the y-axis. So the y-axis is x equals 0. That is literally what the y-axis is. So if x equals 0 everywhere on the y-axis, take this function and replace x with 0. You may already be able to tell that all that will be left is the 50. So we're going to see what this equals when I replace x with 0 everywhere. So that's going to be a 0, where it goes in the parentheses, and the x here becomes a 0 as well. So now I've got 0 squared plus 15 times 0 equals plus 50. So that's just 0 plus 0 plus 50. And that's going to be 50, because nothing plus 50 is 50. And our y-intercept is going to be 0, comma, 50. Remember, x comes first, and x is 0. Y comes second. Let's take a look at our next question. We have a reference, once again, the standard form, ax squared plus bx plus c. I'm just going to copy this equation here into the answer area, and let's identify a, b, and c. All right, so a is the coefficient of x squared. So a equals 3, but not 3x squared. B equals negative 5, but not negative 5x. And C is going to equal negative 8. So 3, negative 5, and negative 8. In our next question, you're going to be given if you took the b squared minus 4ac, which is the discriminant in a quadratic, we're going to see what that's going to equal. Okay, so I'm going to go ahead and take it all the way to solving the quadratic formula too. But let's start dealing with things here. So b is -5. And then a is 3. And c is -8. Okay, now we've got to simplify all of this. So -5 squared is 25, because -5 times -5 is 25. And then, let's see, 4 times 3 is 12 times -8. That's going to be 12 times -8, or -96. So we're doing a minus, which means overall that becomes plus. And now we just need to put that together. And 25 plus 96 will equal 121. Okay, so that's going to be very convenient for us in our next stage, which is, let's just go ahead and use the quadratic formula to solve this whole thing. I'm going to grab the numbers here. Actually, I'll just grab the equation. And we're going to take that equation over for a little stroll to Desmos. Graphing calculator. And there's our equation. You can see the equation nicely. I'm going to turn it off, though, so it doesn't distract. And we're going to say -b plus or minus the square root of b squared minus 4ac. That's all going to be over 2a. Now, I didn't do the minus version. I'll do that later. So my first step is to replace the letters with numbers. So a is 3. So wherever a shows up, we're going to say times 3. B is -5. So wherever b shows up, we're going to say -5. Negative of -5. And then c is -8. And now we're going to work the whole thing out. And you can see that we've got 2 2/3, which is about 5/3. Let's start simplifying this thing, though. Okay, I'm going to copy that. And we'll start by simplifying the denominator. That's going to be 6. And we already worked out that the numerator, that this square root here, was going to work out to 121. Actually, I'm going to go ahead and work it out here. That was the 6. So this 5 squared, again, is 25. And 4 times 3 is 12. And 12 times -8 is -96. And that's going to just be minus a minus, so that's plus 96. And that comes out to 121. And so now we're ready. One more thing. Let's get rid of this minus because that'll become positive. So one more thing. We need to make the minus version. So the square root of 121 is going to be plus or minus. And now we get the square root of 121, which is 11. Okay, so we got -11 and plus 11. And now we just simplify. Okay, so 5 plus 11 is 16. 16 over 6, that becomes 8 over 3. So I misspoke. It's not 5 2/3. It's, what am I saying? So it's 2 2/3. So 8/3 is not 5/3. So 8/3. And then here we're going to have 5 minus 11, which is going to be -6. And -6 over 6 is -1. And those are, in fact, the x-intercepts for this quadratic, which I'll turn on now. So we got -1 and 8/3. Okay, and on that note, I will go ahead and stop. I hope that was helpful to you.